In this video, we'll be looking at the end behavior of rational functions. Basically, a rational function is just a function that's written as a fraction, and our simplest rational function is the function f of x equals 1 over x. So let's take a look at how that function behaves. I'm going to set up a XY chart and look at the graph. When x is 1, y is 1 over 1, which is 1. So we have the point right here. When x is 2, we have the y equals 1 over 2. So we have this point. And when x is 3, we have 1/3. And when x is 4, we have 1/4. Now notice that we're getting closer and closer to this axis, this horizontal axis. Also, let's let x equal 1/2. When x is 1/2, we have 1 divided by 1/2, which is the same as 2. So when x is 1/2, y is 2. And let's just let x be 1/4. We can see 1 divided by 1/4, so y will be 4. So when x is 1/4, y is 4. So in quadrant 1, our curve looks like this. Notice that our curve gets closer and closer to the horizontal axis, but will never cross. And the reason for that is because we can never have a 0 here. This fraction can never equal 0. Also, we get closer and closer to our vertical axis, but we never cross. And the reason for that is also because x can never equal 0. These are called asymptotes. So we have a horizontal asymptote at y equals 0. That's this axis right here. And we have a vertical asymptote at x equals 0. And that's this vertical line right here. So we indicate our asymptotes with dotted lines to show that our curve will never cross this vertical asymptote, because x can never equal 0, since that's undefined. Now let's take a look at when x is negative. If x is -1, we have 1 over -1, which is -1. So we have this point right here. When x is -2, we have 1 over -2. So x is -2, y is a -1/2. When x is a -4, y is a -1/4. That's there. So again, we have that curve that's getting closer and closer to the axis, but never touching it. Let's do fraction, also when x is a negative 1/2, we have 1 divided by negative 1/2, which would be negative 2. So when x is negative 1/2, y is negative 2. And when x is negative 1/4, y is going to be a negative 4. So I'll leave this point right here. So the curve on the left side of our y-axis looks like this. Now this curve, again, let me remind you, is never going to cross this vertical asymptote. Never going to cross this horizontal either. So we would indicate our domain as from negative infinity up to 0, and then pick it up again on the other side of the 0, and then go to positive infinity. Our range is similar. We would go from negative infinity up to 0, and then start back up on the other side of my x-axis and go up to infinity. Another basic rational function is f of x equals 1 over x squared. Let's take a look at what that looks like. We can see, though, right from the beginning that we're going to have a restriction on our domain. X is never going to equal 0, so I can draw my vertical asymptote in immediately. And just like with the previous graph, this whole fraction will never equal 0, which means y is never going to equal 0 either. So I have a horizontal asymptote at y equals 0. Now let's look at some numbers. When x is 1, y is 1. When x is negative 1, we have 1 over negative 1 squared, and so that's also going to be equal to 1. When x is 2, we have 1 over 2 squared, which is 1/4. When x is negative 2, we have 1 over negative 2 squared, which is also 1/4. And let's see, when x is a negative 1/2, we have 1 over a negative 1/2 squared. Negative 1/2 squared is 1/4, so this is 4. So when x is a negative 1/2, y is 4. And also, let's do positive 1/2. When x is positive 1/2, I have 1 divided by positive 1/2 squared, which will still be a positive 4. So when x is a positive 1/2, y is 4. So we have our curves similar to our previous example, but we have a thing that looks kind of like a volcano. It's closer and closer to up to 0, pick it up on the right side of 0 and go up to positive infinity. So negative infinity to 0, union 0 to infinity. And then our range, we don't have anything down below the x-axis. We start at 0 and go up. Do not include the 0 on that one though. So 0 to infinity is our range.